We've had the first images back from Phoenix on the northern plains of Mars, and it's a stunning sight. Close to what we expected, I imagine, but with surprises already in store. Patrick, it's wonderful to see these images already.
Quite incredible. NASA have done a splendid job. Not only they got the probe there, they've sent the images back so quickly, but everything so far has been nominal. Its Phoenix has come down almost exactly where it was intended, and the surface is very much as expected.
Well, with us to explore the surface of Mars, we have Doug Ellison from Unmanned Spaceflight and Peter Grindrod from University College London. So let's take a look at the first images Phoenix sent down. We're looking now at the solar panel fully open. That's the first thing to say, Doug.
This is the solar panel that's pointing towards the east. We heard earlier that we're about 0.68 of a degree off a nominal perfect east-west orientation. So this is looking due east. And we're seeing a perfectly deployed solar panel. It's a 3-frame mosaic, and we're looking at something about 6-7 feet across here. It's quite a big piece of solar array, but it's perfectly deployed, nominal, exactly what we wanted to see, these kind of initial key deployments.
And this was our first glimpse, Pete, of the surface. And what did you get from looking at this image?
Oh yeah, this was the image that got me excited straight away. Well, just beyond the solar panels, you start to see the surface, and you can see the darker stuff, which is fine-grained sand, even sub-sand sized, very fine stuff, kind of the same kind of size as maybe flour, that kind of texture. And then scattered around, we see small stones, probably. I'm not too sure what they are yet. And we kind of guess they're a couple of centimetres across, maybe 5 centimetres or 10 centimetres in the largest case. But right down to what we can see here, less than a centimetre. No kind of general pattern to them. We've not seen any rounded ones yet in this image, I think, but maybe not a good enough image yet to check on.
Well, let's move on. That was the first image. The key thing there is that the solar panel was deployed successfully, and we can see that even more clearly in the next image.
This is the western solar panel, and of course, with the sun being lower in the west in the afternoon, we're getting the glare off the solar panel here. But again, a beautiful nominal deployment. And a bit too contrasty to see much of the terrain beyond. I'm sure we could probably pull something out of that, but it's just another nominal deployment, all good signs.
So let's just get the geometry right. We're looking to the west.
Yes.
The time on Mars is...
This is kind of late afternoon.
So we're looking almost into the sun here.
Hence the glare off the panel.
And although this is darker, this is actually just a shorter exposure, all the contrast is...
We are in the Martian Arctic, so the sun won't actually set.
That's right, it gets just a few degrees above the horizon.
Yeah, about 3 degrees above the horizon.
But that's why we're there. And the key thing here is, of course, both solar panels deployed.
Fully deployed.
What difference will that make for the mission?
Well, it means they can do everything they ever planned. One panel deployed would have been kind of a compromise. What can we manage to achieve? With this, it's a full nominal mission, all guns blazing, everything they want to try and achieve.
Well, that's 2 solar panels. If we move on, then we see this image won't mean much when you first see it, but something crucial has happened here.
Yeah, this is looking at what is essentially the elbow of the robotic arm. Now, the fact that we can see the elbow means this kind of crinkly foiled mess that runs from the middle down towards the bottom is the folded back biobarrier, showing the robotic arm into the Martian environment. This is actually going to be looking southwestish from where the camera sits. The robotic arm deployed and ready to go.
And when will the arm be deployed?
It's probably going to get moved in kind of a half parking position over the next sol or two, and then start hitting the surface 3 or 4 sols from there.
And Patrick, I mean, this image clearly illustrates how this is different from Viking. You wouldn't have seen such a sophisticated joint on the Viking.
After all, this is entirely different from Viking. We've come a long way since then. It's far more sophisticated, and we'll do far more.
And in a different place on the surface. So it's good to see that's working. So the 3 things we wanted to happen quickly were the arrays to deploy, this bio barrier to retract, and the camera to
yes, exactly.
reach position.
The hidden story in every picture is that we're 6 feet off the ground, so the camera must have deployed.
Well, let's move on. And this is it's hard to make.
It's
what to make
another
of this.
obscure one. It's the bio barrier is all folded away at the bottom there. Again, having deployed fully out of the way so the arm can move. And the black feature at the top is actually the scoop of the robotic arm, folded up against kind of the wrist area of the arm. And the bright feature towards the top right, kind of serrated feature, that's actually a part of a scrape that can scratch away at the icy surface if it gets a bit tough going. And then just to the right of that, you can see a small projection out the back of the kind of the bucket of the scoop, and that's the rasp they can use to kind of grind and chip away at the ice if it becomes too hard for the robotic arm to use.
So ready for action, and if we look on, we can see Well, let's have a proper look at the surface. This is one of those shots that you want from every mission. Remember the equivalent of this from Viking?
I do indeed.
The pad on the ground, and well, a geologist size. What do you see?
Oh, happiness! Look at the footpad. The footpad's down on the surface. That's what we want to see. No kind of big rocks underneath the footpad. We know that the tilt's very close to zero, so it's not kind of resting on the rock. It looks really powdery to me, really fine grain mostly, but then there's a whole kind of host of different sizes of I guess pebbles, rocky stuff there. We've had a look at the stereo of this very briefly, and you can see that some of these rocks are poking a good kind of few centimetres maybe up from the surface as well. So that maybe they go down a similar kind of distance, we're not too sure. But we could also see that the footpad looks like it's pushed some of the fine grain stuff up towards the top right of the image. So there's actually a small kind of trench around the footpad where it might have moved a little bit or pushed some of the fine grain stuff away.
It is a very firm surface, that's the main thing.
Yes, it hasn't sunk that far down. We estimate maybe a centimetre of that or a bit further.
It's barely dented the surface.
What does the fact that the surface is so powdery tell you? Does that mean it's dry, or is am I applying things I've learned on Earth?
Well, the upper surface will definitely be dry. The surface will be. I don't know what it means.
Doug, how does this compare to what the rovers have seen?
I must admit, some of the very earliest images I saw were quite a bit like some of the kind of the secondary impact craters around where Spirit landed. It seemed a bit sandy with the odd little rock here and there. If you wanted to go roving here, it'd be fantastic. That's not what we're here for.
No.
But I'm thinking it's ideal. It's what we expected. It's everything we could ask for.
Sure, this almost reminds me of a lunar image, like a surveyor image or something like that. It looks so kind of powdery, so fine. The texture looks completely different to the sand size stuff that we see, to me anyway.
It's smaller grains than sand.
Yes, it's a lot. Yes, to me. Some of the stuff.
Patrick, you're the expert on this territory. A lunar image?
Quite different, of course, with the entire surface differently constituted, but there's a superficial resemblance, but it is only very superficial.